Welcome to ACI, the Network Made Simple learning series. In this video, we will cover Module 3, Configuring Logical Connectivity, Chapter 5, Wrap-Up and Best Practices. In this module, we learn the logical network configuration constructs as well as the configuration needed to have full switched and routed connectivity in ACI. I will be adding extra chapters to the module as needed, so stay tuned. In the next sub-module, we will now take the same ACI concepts and we will apply them to the different cloud providers such as AWS and Azure in order to accelerate cloud migrations and adoptions with less risk. But before we do that, let's cover a few recommendations, additional concepts, and best practices to wrap up this module. Let's get started first by covering snapshots and rollbacks. Let's imagine the following scenario. You have a network with 30 switches. It's a Tuesday night right before your company's peak season starts, and the new intern decides to delete a line from an extended access list on one of those 30 switches. You get there the following morning and the network is down. With this in mind, how long would it take you to identify the error amongst all those 30 switches so that you can troubleshoot and recover the network? Probably a while, right? This is where snapshots and rollbacks may help. Since you can take a snapshot of your network configuration at the system or tenant level, either manually or periodically. This means that if somebody makes a change, such as deleting an entire application profile, you can simply roll back to any point in time with no troubleshooting involved. I strongly suggest you configure snapshots once the network is ready and every time you reach a milestone. Keep in mind that snapshots only work at the configuration level. Therefore, they do not substitute full backups, which also have tech support and core log files, amongst others. Now, in terms of resource and policy scalability, there are a few features that can help maximizing switch and TCAM resources, especially in large network environments. The TCAM is a specialized high-speed memory, part of every Nexus 9000 switch, and it is where policy configuration is stored. The more contracts we have in our ACI configuration, the quicker the TCAM may fill out. TCAM sizes vary per Nexus 9000 model, and commonly provide plenty of space for most organizations' policy needs. However, as networks grow in size, keeping track of TCAM available space may become handy. This can be easily monitored through the APIC in the Operations tab, where you can also adjust per switch CAM scalability through profiles if you'd like, or on the Nexus dashboard inside its Nexus Insights package. ACI creates new TCAM entries for every EPG pair, even if the same contract is used. Therefore, understanding how to optimize contract and resources usage is important, especially for large networks. There are multiple elements we configure with ACI logical networking, such as VRFs, EPGs, contracts, bridge domains, and subnets, all of them consuming switch and TCAM resources. ACI contracts are bidirectionally by default. Therefore, we do not need to separate configurations for inbound and outbound traffic policies. ACI programs two TCAM entries when using bidirectional default contracts. By default, both network and policy configurations are programmed on every switch on demand. This means that TCAM and switch resources are consumed only when needed. ACI determines where and how to program both logical network elements and policies based on its resolution and deployment immediacy settings. Resolution immediacy controls where VRFs, bridge domains, and SVI should be deployed, and it is configured when associating a VMM domain to an EPG. Keep in mind resolution immediacy has no effect on physical domains, as they will always be resolved immediately. Deployment immediacy controls when contracts should be programmed in the policy CAM, and is commonly configured along resolution immediacy for VMM domains, and at the static port level when configuring it for physical domains. Although on-demand default behavior usually fits most network implementations for both resolution and deployment immediacy, understanding how each setting affects resources and TCAM usage may be useful. In terms of resolution immediacy, we have three options. 1. Pre-provision. This means that as soon as I map an EPG to a domain, ACI will program the corresponding VRFs, bridge domains, and subnets on each leaf that has that domain configured through an AEP. 2. Immediate. This means that ACI will only push the configuration after mapping an EPG to a domain only if it has established a CDP, LLDP, or OpFlex relationship between the leaf node and the other end, such as a virtual switch or ACI virtual edge, for example. 3. On demand. This means that ACI will wait until there are actual VMs or hosts using such EPG or port group before pushing the configuration. For example, after a VM has been assigned to the port group. In terms of deployment immediacy, the options available are immediate and on demand. As you can imagine, on demand is the most efficient option in both cases, and therefore it is commonly the default value. There may be a few scenarios where you may want to change the default behavior. For example, if your hypervisor host is 2 hops away from the leaf, or you don't have LLDP nor CDP enabled between them, you might want to change resolution immediacy from immediate to pre-provision. Also, if you have VM kernel adapters or hypervisor management adapters connected to the ACI fabric, in addition to the hypervisor VM adapters, a CDP-LLDP relationship won't be formed until you provide connectivity. Therefore, pre-provisioning may be needed for such environments. As a side note, keep in mind that when microsegmented EPGs are used, the default deployment immediacy resolution is set to immediate. As we perform our ACI configuration, the way we have learned throughout this module, there are multiple things ACI does internally behind the scenes, such as assigning multiple classifiers to each object we create. For example, VRFs have automatically assigned scope IDs, which are the VXLAN network identifiers or VNITs. We can see each VRF scope ID by issuing the show VRF detail command. This may be useful, especially if you want to see the program rules on each leaf by using the show zoning rule command, which requires you to specify the scope ID. As you can see, multiple policies are implemented by default along those defined by the administrator. The important part of this output is that instead of showing each EPG by its name, which would make the output too long, ACI assigns an identifier to each of them called class ID or PC tag. We can match PC tag values to EPGs by issuing the command show EPG detail on the APIC CLI or directly on the GUI. In terms of configuration, we can also limit how contracts are used by defining their scope. By default, every contract we create has a VRF scope. This means that it can be used to communicate different EPGs in the same application profile or in different application profiles, as long as they belong to the same VRF. There are other scopes which may limit this further, either at the application profile level, at the VRF level, or even globally, allowing contract usability even across different tenants. You can adjust the scope of a contract any given time as shown. Let's now cover a few additional configuration options that may impact TCAM's usage. First, unenforced VRF. As covered in episode 1, part 1 of this module, this option is enabled at the VRF level, and it means that all communications will be allowed within the VRF without any contract configuration needed. This obviously reduces TCAM consumption. However, some features like service graphs, PVR, and even quality of service cannot be configured when this option is used. This is why VCNE may be useful, allowing you to reduce TCAM consumption without losing features. VCNE represents all EPGs in a VRF, including its L3 outs, and it can be used as consumer, provider, or both. If you want, for example, to communicate all the EPGs in a VRF to a specific EPG containing the web servers on port 80, just drag the NE icon on your application profile and then create a contract between both the VCNE collection and the provider EPG. That's it. All EPGs will now have communication to the web EPG on port 80. If you want a similar outcome than the one provided by unenforced VRF, just configure VCNE to be both provider and consumer by specifying a permit all filter in each section. VCNE is useful since you do not need to create contracts for every EPG pair as usually required, which optimizes TCAM utilization. Keep in mind that VCNE can also be used across VRFs with the corresponding VRF linking configuration, which is out of the scope of this chapter. There's another option we can use called preferred groups. When you enable preferred groups at the VRF level, you can assign any EPG to become a member of such preferred group. Any EPG that is part of it will have unrestricted communication inside the preferred group, while any EPG outside the preferred group will still require a contract. Keep in mind that you cannot use VCNE and preferred groups at the same time, since the latter is a subset of the former. To enable preferred groups, just go to your VRF, And in the Policy tab, click on Preferred Group Enable. Then, inside each EPG you want to belong to the preferred group, just enable the option and you're done. Last, and only for your reference, there are two more options that may be useful to know about. The first one is contract inheritance, which means you can assign an EPG to inherit the contract of another master EPG, simplifying your configuration. You simply configure it by going to the EPG and in the General tab, specify the EPG contract masters you want to inherit contracts from. That's it. The second one is policy compression, which consolidates the default bidirectional contract entries into a single one. Keep in mind that enabling compression disables individual filter rule statistics, and it may have other restrictions. Policy compression can be enabled when you create a new filter in the directive section. As of ACI 5.0, a new concept called Endpoint Security Group, or ESGs, became available. ESGs are security zones that, unlike EPGs, are not bound to bridge domains. ESG membership is defined based on matching attributes, just like microsegmented EPGs. Therefore, endpoints that match such attributes will be dynamically assigned to the same ESG. Endpoints in the same ESG will have communication by default, even if they belong to different EPGs. This separates connectivity, which is still defined at the EPG and bridge domain level, from policy. ESGs can communicate to other ESGs and L3 outs through contracts. However, ESGs cannot communicate through contracts to EPGs. If you need to communicate ESGs and EPGs, VCNE and preferred groups can be a great option. To configure ESGs, just go to your application profile, right-click on ESG, add a name to it, select the VRF you want to run it, and then choose the right selector in order to match endpoints to this ESG based on its attributes. Finally, when integrating legacy networks to ACI, we cover the static EPG binding as the preferred method to extend a VLAN on the legacy side into ACI. This is achieved by classifying incoming traffic based on the interface where traffic is being received, along with its VLAN ID. This is very convenient for migration scenarios as well, since no contract is required. Keep in mind, VCNE and preferred groups could also be used for migration purposes. There's another option that we did not cover in order to integrate layer 2 domains, which is called L2 out. Contrary to extending the EPG, L2 outs require the creation of an external bridge domain in the access policy section and stretches the bridge domain through a specific port. The main difference with static EPG binding is that L2 outs require contracts to communicate with EPGs, even if the same bridge domain is being used. This is why static EPG binding is the preferred method when integrating external switches and layer 2 connections. As a summary, you now know multiple ways to connect pretty much anything into ACI, and even a few tricks to verify and optimize ACI's operations. Make sure you pick the model that your organization needs, whether that's a pure connectivity model, using ACI mainly as an automated network, or by leveraging the policy model with the right level of contracts your organization may need. Keep in mind that when using multiple L3 outs, it is recommended to classify the right subnets on each L3 out EPG instead of using quad 0, and that you should always optimize and recycle every time you can as a best practice.
ACI provides you with a better, simpler, and secure network, any size, anywhere, and on any cloud. If you want to learn more about other common tasks and how ACI radically simplifies network provisioning and operations, please watch the rest of the videos in this series. Thanks for watching.